Hello everyone, we are from Kokaraju Rangaraju Institute of Engineering and Technology. We have done our major project on an error minimizing framework for localizing jammers in wireless networks. We are a team of 5 members with Aishwarya, Hema, Deepika, Soumya and myself Madhvi. We have done the project under the guidance of G. Karuna ma'am. So we do know that the jammers disrupt the communication in a wireless network, but day by day the use of wireless technologies is increasing, making the radio environment crowded. There are different communication technologies yet sharing the same spectrum like Bluetooth devices, cordless phones, Wi-Fi network adapters and microwaves. So in a wireless communication, all these can act as jammers. In our project, we will be locating these type of jammers to provide better communication. Even earlier, there are jammer localizing schemes, but they utilize the indirect measurements like the hearing ranges. This makes it difficult to localize the jammers accurately. But to ensure the successful deployment of wireless networks, it is crucial to localize jammers accurately, so that there can be a better physical arrangement of wireless devices for better communication. In our project, we will be using direct measurements like the packet delivery to locate the jammers accurately. We will be locating the jammers one by one so that there would be no jamming effects overlap. We have implemented the jamming signal strength to locate jammers. So this is the system architecture. Here we can see three types of nodes: jammer node, boundary node and unaffected nodes. The unaffected nodes are barely affected by jamming and may not yield accurate JSS measurements. The jammer node is jammed by the jammer. They can measure JSS but cannot report their measurements. But whereas the boundary nodes can measure the JSS and can also report their measurement. So we are using the boundary nodes to measure the JSS. By using these measurements, we will be estimating the jammer location very near to the real jammer. So here we are having three modules: client, server, jammer or router. We have shown the simulation of the server, how server sends the files to the client through selecting a better path by avoiding jammers in between. So here this is the client window. Here we will be selecting a path of where to store the receiving file, and then on the server side we will be browsing the file, which file to send to the client, and there we will be giving a IP address of the router through which we want to send. Then we will be clicking the transfer button, and this is the router. This is here it shows the path of from where the server sends and where the client receives. We will be locating the IP address here, which is the router by which we will be transferring the file. Coming to the execution, we are using the Visual Studio to show the simulation of the server and clients. So this is the router window. And this is the client window. In the client window, we will be giving the path where we want to store the received file, and then on the server side we will be giving the IP address of the router through which we want to send the file, and then we will be browsing the file what we want to send to the client. Here I am choosing the wireless file to send. Then on the router side we will be giving the IP address, the same that is given on the server window. Then on the server side we will be clicking the transfer button. It will be connecting to the server and the file will be sent. The file is transferred. And coming to router window, it will be showing the path where we are through which we are sending our file. So here the blue ones are the boundary nodes and the black ones are the unaffected nodes. The red are the jammers and through the green are the routing path through which we are sending our file, and on the client side the file will be received. This is our project. Thank you.